Welcome, student, to this part where we will discuss the derivative of the logarithm. First of all, we are asking ourselves what will be the derivative of ln x, and we would like to write the formula that we will be memorizing and we will use whenever we need to find the derivative of the ln. Now, what is the derivative of the ln? It is very simple. Ln of x is just 1 over x. As simple as it could be for this one. Now, how about if we don't have an x, we have another function which is u, which means we need to use the chain rule. Now, remember, in order to do the chain rule, we need to find the derivative of the outer, which is 1 over whatever inside, times the derivative of the inside, which is u dash. So what you need to memorize is the derivative of the ln is 1 over whatever inside the ln, and in the top we write the derivative of the inside. So we write the inside the ln down and the derivative up there. Let's see a couple of examples where we will apply this formula, 1 over the inner function times the derivative of the inner function in the numerator. So the first question is we need to find y prime. And what is y prime? Remember, if we have ln of u, it is u dash over u. So it will be x squared. And now you do the derivative of x squared, which would be 2x. Now this we can simplify it to 2 over x. Next question, y prime equal. In the denominator, we write the function as it is. In the numerator, we just write the derivative of the function, and derivative of 2x plus 3 is just 2. In this question here, we need to use the product rule. So we have y prime equal derivative of first times the second plus first times derivative of the second. Now, first of all, what is the derivative of x? We need to write it here, and derivative of x is just 1. Next, we have ln of x, so we have ln x here. Next, we have x times what is the derivative of ln x? It's just 1 over x. Now, if we simplify all in all, we will get ln x plus 1. So it is ln x plus 1. And that's the final derivative. Here we just use the product rule. Next, remember, if we have ln of u, what we need to do, we write u down and u dash up. So this question will be u prime equal u, which is ln x, times the derivative of u, which is 1 over x. Now, if we simplify this one, you get 1x ln x. And that's what we get. So remember, this is u, and this would be u prime. Next, we have to use the chain rule. Remember, we have an inner function to the power of 5. So in order to find the derivative, you need to find the derivative of the power of 5, which is 5 something power 4, and you keep ln x inside. After you finish, you find the derivative of ln x, which is 1 over x. So the final answer will be 5 ln x power 4 divided by x. Next, please, I want you to focus with me. We know what is the derivative of ln x, but do we know the derivative of log? The answer is no. So the first step, I will change the log into ln. Remember, if you want to change log xa, it will be ln x divided by ln a. Now, we can easily find the derivative. So we get y prime equal ln a is just a number, so we keep it. What is the derivative of x? It is 1 over x. So all what you need to do is to write 1, and you can write x here. So we get 1 over x ln a. Next step, we need to find the derivative of this log, which is will be ln 3x squared divided by ln 10. Why ln 10? Because what is the number that I don't write here? This number is 10 because this we call it the common logarithm. Now we just need to find y prime. So the first step, I will keep ln 10, and then you need to do u and u dash. So what is u? U is 3x squared and u dash is just 6x. So all in all, this will be just 2 over ln 10x. That's the derivative of the log. Next step, we will use the product rule with the chain rule. So just let me write this comment here. We will use the product rule and the chain rule. Now, what is the product rule? Remember, the product rule equal derivative of first times the second plus first times the derivative of the second. Now I just need to fill in those gaps. First of all, the second will just be the ln first, and then we have 1 plus x squared power 5. Now what is the derivative of something to the power of 5? Remember, something to the power of 5 will be 5 to the power of 4, and whatever inside will stay as is, and then we find the derivative of the inside, which is just 2x. So this is the chain rule for the power of 5. Next, or finally, we have ln u, which is u, and in the numerator we write u dash. So this will be just 1 plus x squared 2x. And that's the final answer. Very simple, very straightforward, using product rule, chain rule, and how we find derivative of the ln. Next question, I would like you to put so many attention to it because it's the same idea. However, it's kind of complicated. So this is u, so the answer will be u dash over u. But the only thing that we need to do is finding the u dash. What is u dash? It is 1 derivative of x. Now, what is the derivative of the square root? It is one of the famous ones, which is 1 over 2 square root of, and you keep the inner function, and then you need to find the derivative of the inner function, which will be 4x cubed. Now, this one you can write it in a better way. So it will be just 1 plus 2x cubed divided by the square root of 1 plus x4 divided by x plus square root 1 plus x power 4. Question number J, we will use the properties of the ln. Now, this question, don't deal with this as u. This is not recommended. In this question, we will use the properties of the logarithms to simplify the function. What do I mean by simplify the function? Look, first of all, this function you can write it as everything to the power of 1 over 3, where you have x cubed minus 1, and then you have x5 plus 1. Now remember, if we have 1 over 3, this number will go down. So it will be 1 over 3 ln x3 minus 1, x5 plus 1. Now remember, if we have a over b, the answer will be ln a minus ln b. So this would be just 1 over 3 ln of the first minus ln of the second. And now you just need to find the derivative. What is y prime? It is 1 over 3. And then what is ln u? Ln u, just x cubed minus 1, 3x squared minus x5 plus 1, 5x power 4. And that's what we have here. So sometimes we can deal with the derivative if we use the properties of the logarithm. The logarithm will be more simplified and we can deal with it with an ease. Next example, number 2, we need to find the fourth derivative. That's a nice question. So first of all, we need to find the first derivative, which will be 5 over x. And let me write 5 over x in this way. You will see why I'm doing it in this way. Because now it is easy to find y prime. What is y prime? Take minus 1 down here and subtract 1. So you will get minus 5x negative 2. Next, find the third derivative, which will be minus 2. You will take it down, so you multiply it by negative 5. So it will be 10. X to the negative 3. And finally, y to the fourth derivative will be take negative 3 and multiply it by 10. So you get negative 30 x negative 4, which we can write it as this way. And that's the answer for the fourth derivative of this function. What we will do next is we will do an example where we use the tangent line. Let's re-practice finding the an equation of the tangent line. So find an equation of the tangent line. Remember, the tangent line, the slope of the tangent line is the derivative. So you have the function, you have the point, we need to find the tangent line. So to find an equation of the tangent line, we need to find a point on the line. Now, what is the point? The point is x equal to 1. So we need to find the value for the y. So take your calculator, substitute x equal 1, 1, 1. The answer will be negative 1. So as a point, you get 1, comma, negative 1. This is x1 and this is y1. We finish from the first part. The second part is we need to find the slope of not any line, the tangent line. What is the slope of the tangent line? You need to find the derivative. Now, what's the derivative? Well, for the derivative, I need to use the product rule here. So the product rule says derivative of first times second plus first times derivative of second. Now, what is derivative of first? It was 1. What is the second? Was just ln x. Times x times derivative of ln x, which is 1 over x. And finally, derivative of minus x is just negative 1. Of course, what I really need is to find m, and m is the derivative after we substitute x, which x is equal to 1. How much m will be? Just substitute 1. The answer would be just 0. Now, finally, we put all those information together. So an equation of the tangent line is remember, it is y minus y1 equal m times x minus x1. Y minus y1 is negative 1. M is 0. And we have x minus x1, which is 1. Of course, 0 times anything is 0. So we get y plus 1 equal to 0. So finally, y equal negative 1. Remember, if y equal negative 1, this is a horizontal line. So we just use the horizontal line, and that will be the... Welcome, student, to do some application in business for the derivative of the logarithm. So in this example, we need to find the marginal revenue function. And remember, once we talk about the marginal revenue function, it means we need to find MR bar or the derivative of the revenue. But what is given to me is not the revenue. What is given to me is the price. So the first step, we need to find the revenue function. So what is the revenue function? Remember, the revenue function, it means the number of quantity sold times the price, which will become 25 Q divided by len Q plus 2. How do we find such derivative? You are right, we need to use the quotient rule. So if you remember the quotient rule, it says that take the denominator, and then we take the denominator times the derivative of the numerator, and then minus, just let me do it step by step. So we take the denominator, we square it. We take the denominator and we just write it down there. And then we find the derivative of the numerator, which is 25. Minus, we do the opposite. We do 25q times the derivative of the denominator, which will be q plus 2, and that's what will be the final answer for this question. Since we don't have values for a q, we don't need to substitute anything. Next question, which is again the same. It says that you have this demand function. We need to find the rate of change. Remember, rate of change means we need to find the derivative. So how do we find the derivative of such function like this? We can use the same idea we just did. If you want, I will just use this idea. So I'll just derivative directly. I will use the quotient rule. You can use any rule you want, but the quotient rule can be used as well. We take the denominator. Now, denominator times the derivative of the numerator, which is 0, minus numerator, which is 400, times the derivative of the denominator, which will be just derivative of len. It's just 1 over whatever inside the len divided by the derivative of the inside. Of course, now all what you need to do, you don't need to simplify this one. All what you need to do is just substitute the numbers given to you. If you substitute 40, this will be 0.52. Of course, this will be dollar per unit. Now, if we substitute 90, this would be 0.8, negative 0.8 dollar per unit. So approximately, those are the answer. So all what we want to say is how to find the derivative of